Good afternoon, everybody. Thank you guys for sticking around and taking a moment to learn a little bit about my company, Mechaspin, and what we're doing with Lidar. It's a little bit different from what you guys have probably seen around this show. I know there's a ton of stuff about autonomous cars and a lot of different mapping applications out there. So I'm really excited to be presenting something a little bit different. Very excited to be here. It's a very exciting time for Lidar. As I'm sure a lot of you guys know, we're finally at a point now where Lidar is at a quality and at a cost where we can now start to use this to solve problems, outside of autonomous cars and really start to get into some really neat stuff. I know you guys are really excited because at some point the continuation and development of Lidar means that when you wake up in the morning and you're on your way to work, you'll be able to jump into one of these guys and continue binge watching Netflix on your way to work that you had quit from the night before. So I know that's great. I know I'm really excited about it. Our company's been doing a number of different applications, which we'll get to here in just a second. But just to give you guys a brief little background on Mechaspin and what it is that we do. So we're a systems integration company that has a background in software engineering and software development. And we use that background to deliver custom solutions for applications and a number of different verticals, but mostly material handling, the maritime industries, as well as car industries and a few different other ones. So without further ado, we'll go ahead and get started. So how did we get here? So we started using Lidar back in 2003 while graduate students at the University of Florida. So this is actually called the Navigator. So this was our first attempt at doing autonomous driving when we were in college. We started with 2D sensors, sensor fusion, and we were just doing basic collision avoidance and route planning. This was a very successful project for us. Although we didn't win the DARPA Grand Challenge, we did compete and we did finish the 170 miles through the desert using the 2D sensors, and that's kind of how we got our start. I'm going to go ahead and fast forward to 2013. So this is called the Automated Mooring System. This is a project that we did in partnership with the United States Navy. And what you're seeing here are big 30-foot robotic arms coming out of a shipping container, and they kind of work like big baseball gloves that have big magnetic vacuum pads at the end. And what they're doing here is they're autonomously finding the optimal attachment point, which is that black dot that you see in the middle. We're finding the optimal attachment point of two ships while they're at sea. So if you can imagine two ships while they're waving up in the ocean, and so that's kind of how we started. So at this point in time, in around 2013, we started noticing a trend. The quality of the LiDARs were getting significantly better. We got into this world of 3D. So this was actually a project that we did with 2D sensors. But we started noticing that 3D was becoming widely available, and it was also becoming affordable. We were getting into price points where we can now look to use this technology in places outside of autonomous car where there wasn't a ton of funding and start solving other problems. So right here, this is a good graph that kind of tells you a little bit of that story. So if you see where we started in 2000, 2002, we're almost paying about 30 cents per point per second. If you look and you kind of go down to the chart, down to where we are today in 2016, 2018, we're paying fractions of a penny for those points at this point. So now, one of our most popular, or what we probably use the most, is the VLP-16, and that's been a core technology that we've used to kind of develop upon. So here's some of the different industries we'll serve. I won't get too much into this slide only because we're going to end up talking about a lot of these different applications as I continue on. But just to give you guys a brief overview of what it is that we're going to be talking about today. So this is the MSx Processing Engine. So once we finished that mooring project, we started taking a look around and we said, hey, other than autonomous driving, what problems can we take this technology and how can we use it to solve problems today? What is it? And so these are some of the capabilities we developed on that project, and so these are kind of where the ideas came from on where we were going to apply them. So just real quick, a quick question. How many of you guys, when you guys return from Las Vegas, are going to be getting into an autonomous car and driving home? We got one. How many of you guys, when you return home, will return to a workplace that you think could be safer, more productive, and more efficient? Anybody? That's right. Everybody should raise their hand because that's true for everybody. For those of you who didn't, you're probably standing next to your boss right now, and you know that's cool too. But if we're being honest about it, in all of our working environments, they can either be safer, more efficient, or more productive. And that's what we aim to do at Mechaspin. We look to solve problems where either safety, efficiency, or productivity is an issue, and we use this as the core technology in order to solve those problems. So this is actually a really cool application. So this is an autonomous strawberry harvester that runs 24 hours a day, 7 days a week in Tampa. So this is a really interesting problem. This company came to us, they weren't able to get insurance until they had a collision avoidance system. So the company, Harvest Crew Robotics, they wanted to utilize a technology that not only could solve that problem of collision avoidance and route planning and be able to do alignment on the roads, but they wanted a technology that they wanted to be able to build on. So that's one thing that I'll point out about LiDAR that makes it a little bit different from the other technologies out there, cameras, so on and so forth, is that this is a technology that gets better over time, right? As we continue to develop these algorithms and as we continue to develop this software, we can actually make these sensors do more over time. We can add to the capability set, and that speaks a lot to what the MSx processor is. For a lot of these applications, and if you look to the right here for each one of these slides, you'll kind of see the highlighted features of each different application. But essentially, we're never starting from zero. We're able to take these different capabilities that we've developed over time and apply them to new problems. If you see over there on the left, essentially what we did on this project is we took 4 LiDAR sensors, mounted them on the top of this robotic harvester, and we were able to merge the data to a point where now we're actually being able to classify people, classify the rows, and do alignment based on those measurements. So some pretty interesting stuff. So this is another very cool application. So we had a customer come to us and they said, so we have this big problem. We are pulling these barges into a terminal, and the way that they measure these now are actually with dipsticks. So they have a guy who goes out there in any weather, any time of year. He's generally wearing rubber slicks and a bunch of winter gear, depending on what time of year it is. He takes a big stick and he sticks it down to the bottom of the river. He pulls it out, and that's how they're getting measurements here. Couple problems there. One, very dangerous, okay? They deal with all kinds of different weather conditions. It's in the maritime environment, so obviously it's going to be wet, it's going to be slippery. In the winter, obviously they're going to be wearing a lot of clothes. I don't know if any of you guys have ever been swimming in a rubber slicker, but it's not the most comfortable feeling that you've ever had. Another big issue that they had here was that if you're off by an inch with that dipstick, that's about 14 tons of material on there. So depending on which side of the transaction that you're on, either the buyer or the seller, somebody's coming out on the short end of that stick. So that's a huge problem. So what we did is we took LiDAR sensors, we mounted them onto a stationary side on the side of the port. So when those ships come in, we're actually able to take a volumetric measurement of these ships using LiDAR scans. So as it comes in real time, we'll actually take scans and we'll be able to measure the draft. So we'll be able to tell you when the boat came in, you were at this draft, and when the boat left the terminal, you were at this draft. And we can tell you within a centimeter or maybe even less what the draft of that boat is. So it's extremely accurate, and now we've actually been able to take those boots off the barge, which is a little saying we use in the industry, but essentially we do not have people walking around these barges anymore. So that's been a significant benefit to the people who are working on this particular application. So this is another really cool application that we've been working on, but damage inspection for shipping containers. So again, just to kind of explain the problem to you guys, we had a customer come to us, and what happens is as these shipping containers make their way to and from their different locations and across the country, a lot of times what will happen is they'll be involved in accidents. Every once in a while they just have a number of different kind of damage, but what happens is the structure of the actual shipping container becomes compromised. It becomes weaker over time. The more damage it has, the more over time. If you guys have ever seen how they stack these things in the yard, sometimes they can stack them 6 containers high. So if you have a container that's at the bottom of that stack is going to collapse. So that's a whole lot of material, that's a whole lot of stuff that are inside those containers that are not only damaged, but it's also going to cause damage to your yard and to your other containers. So this was a pretty significant problem. To come up with a solution for this particular problem, we mounted 2 LiDARs onto a stationary kind of pole, and we can in real time, as this ship comes through, take those LiDAR scans, and with those LiDAR scans and being able to merge those scans, we can actually tell you into the size of a golf ball what parts of that container have been compromised or what parts of those containers have been injured. And that's been a significant advantage to the people working in those particular environments. You're kind of seeing the same thing here. It's a very similar application, but we're doing this for cars. So let me ask you this. How many of you guys have ever looked your car up on Kelley Blue Book? So when they give you those options, there's always 3 or 4 different options, right? So you have, hey, my car's in poor condition, my car's in good condition, my car's in great condition, my car's in excellent condition. And more often than not, what do we all select? My car's in great or good condition, right? We know it's not excellent, like we use the car, so it's not in excellent condition anymore. We don't want to say it's poor because we don't, we want to get as much money as we can. So what do we pick? We always pick cars in great condition, cars in good condition. And that's great, but now with the technology that we're using LiDAR technology, we can actually tell you to a certain amount how much on the outside of the car has actually been damaged. Is there scratches? Is there dents? How does this compare to a perfect model of that vehicle? So this is, a pretty neat application, but a lot of this has to do with, feature matching. When you take LiDAR scans of something, you have a really good idea of what that thing looks like through the eyes of computer, through the eyes of the robotic system. So with this, we can actually tell you, definitively, where your car stands on that metric. Good, great, excellent. I can actually give you a mathematical formula that tells you where your car stands on that. So last but not least, we actually launched this product this year in partnership with Velodyne Lidar. So this is something that actually my buddy Frank Bertini, sitting in the crowd, he came to us and said, hey, every year we go to this show called MODEX. MODEX is a big material handling show, takes place in Atlanta and other places, but this year it was in Atlanta, and he said, and every year we bring our LiDAR sensors, but the big problem is people see the LiDAR sensor, but they don't necessarily know how it applies to them. So is there any way that Mechaspin could come up with some kind of application that shows them how it is that we're using LiDAR in this industry? So we started looking around at the different problems that take place in this environment. And the biggest problem that we found was forklift accidents. Hundreds of people die every single year from forklift accidents. There's billions and billions of dollars in lawsuits and medical care that result from forklift accidents. So this was something that we decided to approach. So we did this application through a company that we work with, Sin City. They're actually in the crowd today. AJ and Natalia, you guys will raise your hands. So we work really closely with a company called Sin City, who develops simulated environments, and they can tell you what synthetic data looks like in that particular environment. It's been very useful for us because we don't actually have to be inside a warehouse or on a barge or anywhere else in order to develop the algorithms needed to make these sensors do what we need to do. We can actually create these simulated environments, and we can create an application just by doing that. This was a really neat project. Obviously we're doing object tracking, collision avoidance, localization, navigation, and people tracking. But to be able to classify people in comparison to the things around them, one thing that's really interesting about forklifts is that not every environment is the same, but you don't necessarily always want the forklift to stop every time it sees something. In the warehouse, you have a number of different things. You have static objects, you have rows all over the place. So it can also be very dangerous if you have a load on the front for that forklift to stop when you don't want it to. So we've actually designed a system that not only classifies people and static objects and other forklifts and can tell you when you're in a dangerous scenario and can have the forklift actually react to those different scenarios. That's kind of our pride and joy right now.